Alright guys, welcome back to my channel. I am Crank Addict and this is the channel for crank addicts like me and hopefully like you. Last time we figured out the spindle assembly for our Lamborghini project here. We settled on CPP spindles using Mustang 2 geometry that are dropped 2 inches. That's important. Go back to that episode if you don't know why. And we decided to use LS1 rotors and Z06 Corvette brake calipers. Now you could probably use the LS1 brake calipers as well, but we did the Z06 stuff. I don't know if they're the same size or not. We're going Z06. But today, we've got to get these wheels attached to the frame, because right now, these things are just rolling around here. So let's get going. Alright, well, let's talk about some of our goals for this race car type suspension. We're using spherical rod ends for accuracy, DOM tubing for strength. We'll be using replaceable screw and ball joints. As far as geometry goes, I'm thinking right now about 5 degrees caster angle initially. 5 degrees caster angle will lead to good high-speed stability, but it may make low-speed turnability difficult. However, this car is pretty light on the front axle, so maybe we'll be okay even with a manual rack and pinion steering system. I would like to keep static camber, how straight up and down the tire is, at a minimum. I'm thinking 1 degree right now. That will give me better tire wear, because these tires for the Lamborghini are expensive. Even the front ones, you go with the factory P7 tires, are $500 a piece. The rears are $1,000 a piece. It's ridiculous. So we don't want excessive tire wear on this car. However, to make up for it, I want to use a little more aggressive camber curve as the tire goes through its suspension travel. I'm thinking 1 degree per inch, which is pretty aggressive for a street car. That's really race territory there. The downside of that is that on braking, as the nose dives, the camber is going to change and you may end up with decreased braking on your front end. But since this is a rear engine car, I don't think we'll be getting a whole lot of dive out of this vehicle anyway, so I'm hoping my choices are safe. I have already measured the wheel rim to the frame, and it's just a hair under 10 inches right now, which isn't too bad for the lower. The upper is a lot shorter than that, unfortunately. But that should give us a good starting base. I've got the center line marked on the frame in case anything moves. We want to pull this body up, and it's time to get going. Well, I actually forgot. I had cut out the 14 degree chassis support across here. I was going to use that for the 84 Corvette suspensions setup, but I decided to change things around a little bit. I'm probably going to drop that to about 10 degrees because I found out that rear engine and mid-engine vehicles don't need as much anti-squat as front engine vehicles. So I'm going to be dropping the anti-squat down to about 10 degrees. We'll see how that does. Okay, but I got to rebuild these pieces real quick before we do any A-arm fabrication. So yeah, let's get to it. Alright, so this is the setup I'm going to be using. This is a 5/8 inch heim joint with 5/8 inch threads. Super strong, almost truck duty there. So that should be real good for a race car. Not quite truck duty. And I'm going to be using them in these prefab plates that I got from Trail Gear. I like these trail gear plates because they're a bit thicker than what you usually see. Most of the plates out there are 1/8 inch. These are 3/16 inches, so a little bit fatter, a little bit stronger. But the problem I have with them is that there's a huge gap underneath there. And if I'm going to be welding these to the side of my frame rail, I want to take out that gap. So I got to cut a 1/2 inch off these brackets before I can use them. Not a big deal though. I'm going to go ahead and demonstrate my manual tubing bender. This is a Amazon bender, but I'm using Eastwood dies with it. And it's very manual. And for those who want to see how slow it is, here we go. I want to show you guys. So I'm using a piece of 12-foot tubing right now. I don't want to cut it down. So it's a little labor intensive as well. So first I'm just going to slide the tubing to the lock. There we go. And it's got to go a little bit beyond the lock. So the bolt can be tightened down to lock the tubing in position. There we go. And I'm just going to mark where it is in case I need to put this thing back in place. The bend is going to start here at the edge of the die. So I'm going to draw a little dotted line there. And then we start bending. Let's make sure this is on 0. Alright, so now we can start bending. Go. I want to advance that 1 notch. And I'm going for a 60-degree bend on this one. Let's see where we're up now. We're at 30. That's about 48. $55. And that's like 62. So when I let this off, it'll probably spring back to about 60 degrees. Take my block out. Set my screw down here. There we go. There's my 60-degree bend. Okay. Alright, finally got it tacked. Let's see how far I moved it. Oh gosh. 5 degrees right now. Yeah, let's see, center line is still good. All right, now let's build the other half. All right. I got the second bar bent and shaped. I'm going to tack it in right there. Got to turn the gas on for that one. Alright, well, here's my first attempt. I know I already want to make a few changes to these bars here. One, I want to take this bottom one here and put it up on top of this rail to lengthen this control arm, because that'll allow me to bring this bend further in. And I'll keep it from hitting the tire. Both sides, front and back. So that's kind of a limiting thing. Plus, by lengthening this rod here, this lower part here, I can get a little bit better camber curve as well. So I'm gonna lock this tire into place, and then we'll remove this this piece here and redo it. All right, guys, this is round 2 of this A-arm suspension. First time through, I was hitting pretty hard on the front, and I redid these front parts here, and now, oh, look at that. That's some serious attitude there. We're gonna start drifting with that kind of an angle. I'm liking that a lot. Let me kind of show you guys from overhead here. There we go, you can see the angle we're at. It's nice. I'll go back the other direction. It's not quite as nice. So although we're hitting about 45 degrees turning in, turning out's only about 40 degrees. And if you look at the way Ackerman's steering works, your turning out tire needs to be a little bit wider than your turning in tire. Okay, so what that means then, like I said, if this is turning out at 40 degrees and the other one is turning in at 45, that's all screwed up. Ideally, this should be probably around 50 or even 55 to really get the car cranked around the tight corners, in case you want to go autocrossing. Road racing is not quite as big of a deal, but yeah, if you want to do some autocrossing, yeah, you want to have those angles dialed in a little bit better than that. So I am running out of room on these back supports here. So this gets a little tricky. I'm already at the minimum length right here, so I can't cut this any shorter. I got a 90 or 80 degree bend to the ball joint. So what I have to do now is I'm actually going to go ahead and untack this back bracket, move it in front. So basically moving the whole thing 1 inch forward, and then I'll just have to cut an inch off here and recope it to fit. The bottom one's gonna be a little bit more tricky. I'm already as far as I can go forward. There's gonna be a post right here. So yeah, I'm leaving just enough room to get to this nut, you know, so you can remove the bolt from the backside. But I've still got a little bit of room here, so I'm I'm gonna have to mark it on the machine, try to figure out exactly where I can cut, but I might be able to take another 1/2 inch out of here. I'm not sure how that's going to affect it up here though. I may have to remake this whole piece. But that's the joy of building your own A-arms. All right, so I went ahead and re-engineered both of these back bars here. I pushed these in about 1 inch or so. New bend, push these. Well, these are, I can't push these in any further, but I put a smaller bend on this one here and pushed it as far into this bung as possible. Of course, that means remaking the whole tube. So, 2 new tubes in place. And when I go full out tilt, that's a nice angle there. That is, I'm gonna call that 45, maybe a little bit more. That's pretty good. That's a pretty hard corner. So I'm pretty happy with that. Now I just need to take these things apart and duplicate them for the other side. Now it's time to test the suspension and see how it performs. As you guys can see right there, showing 88.3 degrees, which means at right height I've got 1.7 degrees of camber, which is pretty nice. It's an aggressive street setting, maybe street/track setting. Yeah, so that's a real good starting point as far as the camber goes. I'm happy with that. But I couldn't get a reading with my analog gauge as far as camber gain through a corner, so we've got this thing here set. I'm gonna jack up the arm and we'll see how much camber gain we have here. So we're at 3.5 inches here. Yeah, let's see here. There's 1 inch. And it's at 88.0, so 0.3. That's a little bit on the mild side. Let's do another inch. There's 2 inches, 87.4. Okay, that's getting a little more aggressive. That's 0.6 degrees per inch of travel. That's not bad. And let's see if we can get 1 more inch out of it. Right up there we go. Okay, so now we're at 86.6 degrees. So our total camber gain is what? So that's about 1.7 degrees gain through 3 inches, or about 0.6 degree per inch. Okay, that's not too bad. That's actually not too shabby. So I was thinking I was gonna have to redo these uppers to shorten them somehow, or maybe, hang on, let me drop this back down to the 3.5 mark, there we go, or maybe even add a little bit of steel underneath here, like maybe a 1/2 inch piece, and bring these down just a hair. Okay, so now I need to duplicate this A-arm for the driver's side. So I traced it out on some paper here. And I'm gonna get an extra sleeve for my, what is it, a 771 ball joint? No, 772 ball joint. And a couple of Heim joints, spherical rod ends. And I will choose from this selection of strategically cut curves to see what fits the best. It's hard to believe that it used to be 12 feet of tubing. So close. So close. Okay, so it seems like none of those angles are going to work out for us. So it's time for a trip back to the metal supply company. Alright, well this is the lower passenger A-arm, and I actually had some cutoffs that fit really nicely. So I can go ahead and tack these together and go ahead and weld the brackets onto the other frame. Alright guys, well I decided to remove this upper suspension support and the bracket here because I wanted to lower it a ½ inch to improve the camber gain through suspension travel. Okay, I was getting about 0.3 degrees of change through 1 inch of suspension travel, and I wanted more. So I did a little test run using some threaded rod and just kind of hang it off the bottom here, and a ½ inch should give me pretty close to 3/4 to 1 degree per inch. So I've cut out this piece of tubing and I've notched it to make it a little easier to go around the existing frame here. I'm going to tie it into this upper here, and there we go. 10.0 is going to be my anti-dive geometry. So I've got these things just slightly tacked into place, and we're going to test the geometry. And again, you guys see that digital gauge right there? It says 88.2, which means we're at 1.8 degrees of camber, which is not too shabby. It's a little aggressive for a street car, but it'll work. And we're going to start, we're at right height right now at the 7, and we want to take it up and see how it goes. I'm going to go ahead and zero this out. There we go. Now it says 0. And let's move this thing. Here we go. All right, 1 inch, 1.2 degrees. Ooh, that's quite a bit. 2 inches, 2.5 degrees. Okay. And can we push 3? I don't think we have 3 inches in this thing, but we'll go to 3. If we were to go to 3, I've got 4 degrees of camber. So with those settings, I feel like I can actually back off on the static camber from that 1.8 to probably about a 0.8 or 1.0 just by lengthening this probably 1 turn, probably all it takes. Bring this out a turn and boom, I'm probably there. Okay, now if I thought those readings were a little bit high, where's my finger? There it is. If I thought those readings were a little high, I could always back off these mounts a little bit. Just by cutting a 1/4 inch off or so, I can raise these mounts up a little bit. That will decrease my camber curve as this thing becomes more even with a lower. All right, here we go again. Take 3. The first time we measured this, we had this upper support, even with that mid bar. I didn't like the camber curve, so I dropped this bar a ½ inch and extended it all the way to the outside edge. Looks pretty cool. I like the look of that. Once it's welded up and smooth, that'll be sweet. But I thought I had a little bit too much camber gain. So I took a ½ inch off these brackets, and we're going to try this one more time. So here we are at right height, starting at 6 inches, and we're going up. And at 1 inch, I've got 1 degree of camber change. 2 inches, 2.1 degrees of camber gain. And at 3 inches, 3.6 degrees of camber gain. That's in comparison to what, 4.1? So we're starting to moderate that down a little bit. I expect this car to have about 3 degrees of body roll going through the corner. So that 3.5 degrees of camber gain is not too bad. I am tempted to try to do this one more time to get it right around 1 degree per inch. I think that'll be the ideal. It's only time, right? Okay, here we go again. Attempt number 4. Okay. So I'm shooting for 1 degree per inch of movement. I have raised this upper arm another ½ inch. That's it. If even that, maybe 0.2 inch, something like that. I didn't want to do too much. And let's check this out here. All right, so we're at right height there. Oh, let me zero this. Come on, 0. All right, there's 0. And there's 1 inch, about 0.9, that's good. And 2 inches, 1.9, I'm liking that. And 3 inches. Ooh, gets a little high there, 3.3, but I don't expect this to be into the 3-inch compression very often. Okay, so back at ride height. I'm going to zero this out. And let's go down a couple inches and see how it looks. Going down 1 inch. We're going 0.7 degrees the other direction. 2 inches. 1.2 the other direction. And that's as far as I can go with my jack. It's about 1.5, about as far as I can go. So if I can run a 1.0 static camber, then I'll actually have about a ½ degree of camber when I'm tossing this the opposite direction. So, you know, not perfect, but it's kind of hard to get the compression and the extension the same. What's more important, of course, is the compression, because that means all your weight is on that side. And for that, we are doing well. Like I said, there's 0, 1 inch, 2 inches, and about 3 inches. So I'm going to burn that in. Done. All right. Well, I'm pretty happy with the geometry that we achieved. It only took 4 tries to get there. The next episode, I think I'm going to go to the rear suspension. I need to hook up a steering system for this, but I really want to get this car on all 4 tires. And yeah, I'm kind of leaning toward that. So if you guys haven't subscribed, hit that subscribe button. Please give me a thumbs up, because that helps us out with the algorithms. And I'll catch you guys next time. Thanks for watching.